Hi everyone, myself Ajay Krishnan B, PG Department of Physics, Kfasc Arts and Science College. Today we are going to discuss about the topic transistors. Transistor is a device we commonly use in electronics. As we know, electronics is a essential part in physics as well as in our daily use, which means that transistor has a significant role in our daily life. Transistor is a three-layer semiconductor which has two p-n junctions. We have already discussed about these p-n junctions. The p-n junctions means a p-type semiconductor as well as a n-type semiconductor. Here in transistors we use two p-n junctions. We can see that in the figures itself, a collector and base and as well as an emitter and base. Here the emitter base is forward biased as well as the collector base is reverse biased. There are two types of semiconductors. We know that it's p-type and n-type. Similarly, there are two types of transistors, which is NPN transistors as well as the PNP transistors. We will discuss more about transistors and its working. This is the basic figures of PNP transistors as well as the NPN transistors. Here the emitter and base is forward biased, which means that the electrons flow from P to N type here in the PNP transistors, and in the NPN transistors also the P is in the base and the two N semiconductors in the emitter and collector. These are the two types we use in the transistor. The working we already discussed that the forward bias is emitter base junction and the reverse bias is the collector base junction. The electrons will flow from base to the working is the forward bias is emitter base junction and the reverse bias is collector base junction. Forward bias, which means that the current electrons flow from emitter to the base and constitute the emitter current IE, and electrons flow from base combines with the holes in the collector and constitute a base current IB. The remaining current is flows through collector, which is called as collector current IC, which means that the emitter current is equal to collector current plus base current, which is the equations we can see here. Now we will discuss more about the configuration we use in the transistors. There are three types of transistor connections, that are common base connection, common emitter connection and common collector connection. The common base configurations and common emitter configuration and common collector configurations. We will discuss each about detail. Common base configuration. As the name suggests, the base is common to the input as well as the output. The emitter is the input current which we gives, and in the collector we get the output. As we can see in the figures, there are two NPN and PNP transistors which we use as the common base configuration. The figure itself says everything. The current amplification factor, which means that the ratio of output current versus input current. In the common base, the output current is the collector current and the input current is the emitter current, which means the collector, which means current amplification factor is the IC by IE. The common base, the alpha is the term we used for current amplification. We will discuss on the topic of common base characteristics. For finding the common base characteristics, we have to collect two ammeters as well as two voltmeters. In common base characteristics, we want to find the input characteristics as well as the output characteristics. To find the input characteristics, we want to find the input characteristics, we want to find the input current versus input voltage, and in the output characteristics we want to show the relation between output current and output voltage. The input characteristics of common base gives a curve like this, that is IE versus VEB, that is the emitter current versus voltage in emitter base junction. These are the input current and input voltage. At a common output voltage, we get the input characteristics, and the output characteristics, the output current versus output voltage at a common input current is found out. That is, the curve is like this. We can see the difference between input current as well as the output current in the graph itself. Similarly, there are two more configurations, that is common emitter configuration and common collector configuration. Now move on to the common emitter, which is commonly we use in every transistor as well as the amplifications. The common emitter configuration. The name suggests itself that the emitter is common into input as well as the output. The emitter is connected to the input signal, which means the input signal is the base current as well as the output current is the collector current. We can see the figures. One is the NPN transistor and the other is the PNP transistors used for common emitter configuration. Here also the current amplification factor, which is the beta, which means the ratio of output current versus input current. That is, here the collector current is the output current and the input current is the base current, which means beta is equal to collector current IC divided by base current IB, which gives the current amplification factor in the common emitter. To find out the characteristics, as we discussed earlier, we have to connect two ammeters as well as two voltmeters into the circuit and supply the voltages. The input characteristics is the characteristics between input current and input voltage at a constant output voltage. Here the input current is the base current and input voltage is the base emitter voltage, and output characteristics is the output current versus output voltage. Here output current is collector current and output voltage is collector emitter voltage. We get a input characteristics as the shown in the figure and the output characteristics as in the figure. In input characteristics, the IB versus VBE at constant voltage at output, which means constant VCE, gives this type of graph in the input characteristics. And the output characteristics, we find the output current versus output voltage, which is IC versus VCE at constant IB. IB means the base current, which is the input current we use in the common emitter. Thus, we can find out the input characteristics as well as the output characteristics. Now, move on to the third and the final configuration we use is the common collector. Common collector configuration. The common collector configuration means the common collector point is common to the input as well as the output. Which means the base is the input signal and the emitter is the output signal we get. That is the current amplification factor, the ratio of output current versus input current. Here in common collector, the output current gives the IE, which means the emitter current, and the input current is IB, which is the base current. That means the current amplification delta is equal to IE by IB, which can be seen in the figure. The two NPN and PNP transistors used in the common collector configuration. Here also we want to find the characteristics. As we discussed earlier, we want to connect two ammeters as well as voltmeters to find out the character. There are two types of characteristics, input characteristics as well as the output characteristics. In input characteristics of a common collector, we find the relation between input current and the input voltage. Here base is the input current IB and voltage is the base collector voltage VBC. At a constant output voltage, VBE. The figure says everything, that is, at constant output voltage VEC and the input current IB and VBC gives the input characteristics, and the output characteristics, the output current IE versus collector emitter voltage output voltage VCE gives output characteristics at constant base current IB. These are the two characteristics we can find from the common collector circuit. These are the three configurations we commonly use using transistors: common base, common emitter, common collector configurations. As we summarize, we can compare the transistor connections with their input impedance, output impedance, gain and its applications. The common base, common emitter and common collector. The input resistance or input impedance is very low in common base and common emitter, whereas the common collector has very high input impedance, and the output resistance or output impedance is very high in common base, whereas it is high in common emitter and very low in common collector. The gain is very high in common emitter, which is, we can see that about 500, but in common base it is only 150, as well as in common collector it is very less than 1, which means the applications we commonly use common emitters in audio frequency applications, as well as in common base we only use in high frequency applications, and common collector uses in impedance matching cases. That means these are the applications for common base and common emitter and as well as the common collector. That's all from my side. Thank you.